In this video, I introduce N-gram language models. N-gram language model is to predict the conditional probability of word W given some history H. Relative frequency counts are used to estimate the probability. For example, we use cat chases as a history H to predict the word W. To do so, we first calculate the counts of 3 words. That means 2 history plus 1 word in the corpus divided by the counts of 2 history. H here is cat chases. Then we found the maximum conditional probability for the word mouse. So we have this sentence: cat chases a mouse has a maximum conditional probability. If corpus is large enough, we can compute this counts and estimate the probability of word mouse following the cat chases. Unigram language model supposes that each word is independent, and the probability of a sentence is equal to the probability product of each word, namely this joint probability for a sentence equals to the product of probabilities for each word. The normalized probability of the word W is Wi is written as this numerator is counts of word Wi in the corpus, and the denominator is total counts for all the words in the corpus. Bigram language model approximates a conditional probability of Wn condition W1 to Wn minus 1 to conditional probability of Wn condition previous word Wn minus 1. That means we use this conditional probability to approximate this conditional probability. So the normalized bigram probability of words Wn given a previous word Wn minus 1 is defined as this conditional probability. The numerator is counts of the 2 words start with this previous word divided by total counts of the 2 words start from previous words. This any words in the corpus. And then we can simplify this sum to counts of the previous word and Wn minus 1. Similarly, the normalized trigram language model is defined as this conditional probability. The numerator is counts of these 3 words start from the history divided by the denominator as a counts of the 2 history words. For a general N-gram language model, maximum likelihood estimate is written as this conditional probability. We calculate counts of all the N words divided by the denominator is the counts of the history words. We don't use maximum likelihood estimate to evaluate N-gram language model. Instead, we use perplexity to evaluate N-gram language models. Here, this perplexity is defined by the joint probability of the sentence, and then now we can further simplify them to the products of the conditional probabilities. Perplexity minus the uncertainty of a sentence. The larger the perplexity, the less likely a sentence is observed. For example, bigram language model, we have the perplexity is equal to this product of the conditional probability of this Wi condition previous was WI minus 1. For more details, please check with this reference. Thank you. Bye.